Okay, we're going to look at the law of sines here. Law of sines is a pretty simple formula or form that we can use to solve for sides and angles in triangles that aren't right angles, or right triangles, sorry. So as you can see, it's set up here where it's a ratio of the three sides and the three angles. Okay, you can see it right here. You got your side A over the sine of angle A, and then is equal to B over sine B or C over sine C. So either or any combination of those three ratios you can use, and you'll see in the first example how we'll pick two that we need to and then go from there. Now you can also see that it doesn't matter. You can flip it over and it'll accomplish the same thing. So you're given this form, same with the law of cosines, which you'll see later, and hopefully it makes as much sense. So here's our first example. We've got a triangle ABC. We've got angle A is 38 degrees. We've got angle B is 62 degrees. And then side A is equal to 12, or some people would call that side BC. And the question says, find side AC. Well, I don't really like that terminology. So when I look at the triangle here, I see that side AC is the same as us calling it the side B. So I'm gonna call it side B, but that's the way I like to do it. But either way, so when you're using the law of sines, you got to ask yourself, do you have a corresponding side and angle? Because if you look back at the formula, you need a corresponding side and angle, either A's or B's or C. Doesn't matter, but it's got to be corresponding. So when I look at this question, I notice I've got angle A and I have side A. So that tells me right away that I can use the law of sines. As long as I got some other piece of information, and I do have another piece of information, I've got angle B. So when I go to write the law of sines out now, I am going to start with my corresponding stuff, and because I'm trying to find a side, I'm going to set it up in this form because the sides are on top. If I was looking for an angle, and you'll see in the second example, I'll use this setup where the angles are on top. So I'm going to start and I'm going to say A over sine of A is equal to B over sine of B. And the reason I'm using that ratio is because I've got angle B. I don't have any information about C or angle C, so I can't use that ratio. So once I have it set up like I do, now I can start substituting values in. So here we go. I can say that little a, or side A, is 12 over the sine of 38 degrees is equal to little b, or side B, side AC in the question it's called, over the sine of angle B is 62 degrees. So now you can see, because we chose to set it up using this form of the law of sines, and it doesn't really matter, it's just what works easiest is what I'm kind of thinking of. Our unknown is already on top. So in order to get it by itself, I'm going to multiply whatever sine 62 is up and out of there. So when I do that, it looks like this. B equals 12 times the sine of 62 degrees, and that's still over the sine of 38. Now, I didn't do any magic there, I just multiplied the sine of 62 up to the 12 there. So, now when I put that on my calculator, the only thing you got to watch is you got to remember that it's 12 times the sine of 62. You got to figure out if you put 12 times sine 62 into your calculator, then hit equals, or if you go 12 times 62, then hit sine, then divide by the sine of 38, and the same kind of thing. So when you put this in your calculator, and make sure it's in degree mode for if you're in grade 12, side B comes out to be 17.2. Oops, forgot to switch back to red, but that's okay. So you should have 17.2 for an answer on that one. Okay, so now let's go and find an angle. I got an angle, or finding an angle question here. A, B, C. Let's go, side B will be 16, side C can be 13, angle B can be 41 degrees, and let's find angle C, or the measure of angle C, however they want to ask it. So again, do I have a corresponding side and angle? That is so important. Corresponding side and angle. That's what I need. To use the law of sines, you need that. If you don't have that, you got to use something else. 180 rule, law of cosines, something to that effect. So I notice this. Now I've got my side B. I've got angle B. I've got side C. I'm looking for angle C. So this is going to work perfect. So I'm looking for an angle, so I'm going to set up the law of sines where the angle's on top, starting with my corresponding one, and then the stuff that I'm looking for right there. Okay, so there is our law of sines with our angles on top, because we're looking for an angle. So the sine of 41 degrees over side B, 16, equals sine of C we don't know. Angle C we don't know. We're looking for it. This is the unknown right there. Over side C is 13. Again, you notice our unknowns on the top. So we're just going to multiply the 13 right up there. So when I write this out, I get sine C equals 13. I always put the side in front of the trig function. It works, I think, better that way for your calculator. It doesn't end up, if you have some of those funky Texas instruments, you have to close brackets. This reduces that. So when I put this whole thing into my calculator, I'm going to get some weird decimal. Okay, I think 0.533 or something. I'll put that down, 0.533. Now, the problem is that's not what angle C is. Angle C is the inverse of that, or the second function of the sine of that. So we're going to hit second function on our calculator. That's that sine -1 thing. And put the 0.533 in. And our angle C should come out to 32.2 degrees. Okay, so it's one of those forms that once you understand the basics, that you're using a corresponding side and angle all the time, you're looking for your unknowns, you put that in the other ratio, and you're just solving for a variable, it's good to go. Just remember, when you're looking for an angle, you gotta second function it, right? Second function when you're looking for an angle only.